Greetings, I'm Salvador Cordova. Welcome to the Evidence and Reasons for the Christian Faith video channel. I'm privileged to be joined by philosophy teacher Danny, and we're going to talk about mathematical Platonism today. That may seem really nerdy, and it is, but it has some importance in this discussion about information theory and intelligent design, and it even does have some connection, I would argue, to the idea of the meaning of function. Uh, uh, Before we came live here, Danny introduced that interesting concept of function. Why does it appear in biology especially? So now I'm really glad to be talking to him about this. And so some other things have come up, and I'd just like to make some announcements. Parents from my church and other places are trying to introduce their children to my work. They're 13-year-old kids, and yes, even that age group. So I'm trying to maintain a very family-friendly climate on my channel. And some of the stuff that I've been seeing on some of the other YouTube channels, that's just not going to fly here. The sort of behavior that goes on, that just can't be tolerated here. For those of you who are parents that have 13-year-old girls, some of these channels, you would not want them seeing some of the language, the foul language and behavior that goes on there. Our channel is not about that. We are trying to focus on keeping the discussion as scholarly as possible. And I just thought I'd make that announcement. We have I formed a separate channel known as the Evidence Reasons Academy, where we focus primarily on teaching science. I'm in the middle of a college level general chemistry lecture series. Please feel free to subscribe to that channel. You can go to my website, www.evidenceandreasons.org, and there's a link to the Evidence Reasons Academy. We are thinking of syndicating our work beyond the YouTube channel, so we're not at their total mercy, because some things, either administratively or just in terms of their philosophical bias, may cause problems for our channel, and it would be good not to be at their total mercy. And so I'm working through that right now. The Evidence and Reasons Academy and this channel may be probably more based through the website than through the YouTube channels. And it's also easier to organize things there than go through the YouTube interface. But today we're going to just talk about some Wikipedia articles. I'm not going to be arguing whether some of the views are absolutely true. I'm going to be arguing that they are fruitful, they're useful, and just in light of that, if it is useful, why dispense with it? It's a proper viewpoint if you're going to operate in certain realms. And information theory, I think, can be best understood with the idea of Platonic forms. And in the way that I'm presenting it, or at least that I'm going to try to argue today, one doesn't have to absolutely believe that Platonic forms, the philosophy of Plato and some of the mathematicians, is absolutely true, but it's a fruitful way of understanding it. And I'm not going to get into arguments about whether information is non-material or material, or if it's supernatural. I actually think those weaken, those are throwing confusion factors into the whole mix, and it's conflating terms unnecessarily. It may be true after all, but it's not anything we need to do to be able to understand information theory and to also prosecute arguments of improbability. So I form my intelligent design arguments as follows. I say, well, maybe in the ultimate sense, it's difficult to formally prove an intelligent designer. We can, however, take our accepted laws of physics and chemistry at probability and our understanding of cell biology and say, okay, at this stage of the game, life is improbable. If we just took straightforward calculations, and I think that's definitely par for science. We understand this starting with Virchow's cell theory, that cells come from pre-existing cells, and then also Louis Pasteur's experiments on spontaneous generation. And we know that it's improbable based on experiment. Maybe the only question is how improbable. And at some point, for some people, if the improbability is extreme enough, they would consider it a miracle. And that's basically it. It's, some of the metaphysical stuff I'll just leave to each individual. But what falls well within the domain of science is to estimate probabilities of events. That's perfectly within the realm of the natural sciences. So with that, Danny, please introduce yourself and thank you for joining. You are just you are a godsend that I would meet someone like you with your background, because you understand so much of the nuances of the debate and also the historical language. There's a lot of terminology I see that I am not acquainted with. Even some of the stuff with mathematical Platonism, it's never taught to me in all of my years studying math, and I spent a lot of years studying math. So same with the engineering. So
Well, yeah, I'm happy to be here. So I'm a student of philosophy. I have my bachelor's in philosophy, currently getting my master's in philosophy. So I guess part of the reason why I'm here is to kind of reflect or give a simple account of, I guess, the term Platonism. Now, there's a lot of misconceptions actually about Platonism, right? That the way that it's used in like today and postmodern circumstances is it's somewhat divorced, although inspired by Plato. Okay, so when you meet a philosopher who is a Platonist, right, that doesn't mean that they hold Plato's original view of forms. Okay, so that's the first thing. Although, of course, we would call someone that held to that really classical understanding of Platonism a Platonist as well. Okay, so the term Platonism is very, very broad now. Okay, it is, at least in the last few decades, have been it's an extreme problem in metaphysics and philosophy, right? And what I mean by problem is that it's widely discussed. There's very little agreement, and it poses a problem for all sorts of domains of thought. For instance, atheists or naturalists, I should say naturalists have a problem with Platonism, right? Because it's going to be very weird to say that the number 9 is natural, right? I mean, people have attempted to naturalize numbers, but the point is that it doesn't make sense to say the laws of nature or natural law somehow governs the number 3. I mean, it's just, when we understand natural things, we're talking about things that cause other things or the effect of other things. They engage in causal relations, right? But we're not ever worried that the number 9 is going to come and murder us, right? It can't do anything, right? It's so that's the first feature of a Platonistic view is that abstract objects like numbers don't cause anything. They don't engage in causal relations. That's one of the central features of Platonism, any Platonist, right? And there's a term for that. It's called abstract. So that which is
I didn't know that, by the way. If I interrupt you, it's sometimes usually just to clarify something or compliment you. I did not know that. So thank you. I learned something today.
We're not scared of the number 3. We're not scared of infinity. We're not in terms of what it could do to us, or we're not scared of producing it in the lab, right? Oh, there's a number 3. We're not worried about that stuff, right? Because it's abstract. So the way abstract is defined actually usually centers around that idea of the lack of causal interaction. There are other definitions of abstract. A very classical understanding of abstract is that it's not in space or time. Okay, which again is going to pose a problem for naturalists, those that want to say that that number 3 exists in some kind of way. Well, if it doesn't exist in space or time, in virtue of what would it be physical? All right. So those two definitions are classical definitions of the abstract and are sorts of properties of numbers that they do exist, right? Now, I will give you a very interesting problem with saying that abstract objects, maybe not necessarily numbers, but abstracta in general, that it can't exist in space or time. I'll give you simple examples of lines of longitude and latitude, like the equator, and the center of mass. These are considered to be abstract objects from many views, right? But they have locations, right? So think about the equator of the Earth. We can point to that. We can say there's the equator, but if you go at that spot, are you going to see a line, right? It's so there's a big. Oh, is that an abstract object? Does it? Are we afraid of equators killing us? You know, like there's, to use an example, right? We're not, right? So there's an abstract thing, doesn't cause anything. It's not the, now is it the effect of something? Well, that's again controversial, right? Obviously, to have an equator, you must have an Earth. Does that mean there's a causal relation? And so there's certain abstract objects that make you really think about the definition of abstracted. But usually with respect to numbers and mathematical objects, this is not so much a problem, okay? But I just wanted to give that side note that there are other abstracta where the definition starts to be a little problematic. That it's interesting to understand how we construe an abstract thing. I don't mind being interrupted. It looks like you want to say something, but so now there are lots of, so one of the responses in terms, so think about this, okay? So here's another way of understanding a Platonist's mind, right? The mind of a Platonist. When I say Sal is a scientist, think about what makes that true, the sort of truth conditions, right? There's a sense in which it wouldn't be true if Sal didn't exist, right? If if Sal passed on in 100 years, if someone knew Sal because he got rich and famous off YouTube, right? To say that Sal is a scientist seems false because there is no Sal. Maybe Sal was a scientist, makes sense. But Sal is a scientist, it makes sense because there is no Sal, no object for us to make a predication of, okay? So now watch this. In the same way that the sort of truth conditions to the sentence that Sal is a scientist require a reference, something that the word Sal is referring to, well, what about 7 is a prime number? Well, there's a predication, right? But what if there's no number 7? In what sense would that be true? So if it's true, the sorts of truth conditions are going to be very different than in the case of the truth conditions for Sal as a scientist. And then there's a huge problem there on your hands, right? They call that the theory of reference. I think it's a meaning. It's trying to get at what meaning is in truth condition. But I don't want to bring that stuff. That's a lot of philosophy and language stuff. But this is one of the apparent issues. When we make a predication of something, of an object, and if that object doesn't exist, it's hard to say to come up with the truth conditions for that statement. So there's a very famous Christian philosopher who's still alive, who taught at the University of Notre Dame. He was a Platonist, right? And his name is Peter Van Inwagen. Now, he takes an extreme form of Platonism, right? Where something like Harry Potter has a scar is true, and there's an abstract object that is Harry Potter, right? In fact, he would go so far as to say that J.K. Rowling did not invent Harry Potter, that she actually discovered the concept of Harry Potter and put it into writing or in a book or something. So there's a lot of stuff that comes out of Platonism that that might be intuitive, but also some unintuitive stuff. How do we make sense of stuff like Harry Potter has a scar, or James Moriarty is bald or something like that, right? Those are going to presumably be true in some sense, but if there's no object, we're going to have a problem. But the Platonist comes in and says these are objects; they're abstract objects. And here's another further claim of Platonism: they exist just as robustly as any physical object. Now that's a little ambiguous of what that means, right? So I'll give you an example to understand what that means, right? Some people think that when we're talking about Harry Potter, we're talking at a hypothetical. Like, so here's our world. Our world's here. Our world's here. And then we have the Harry Potter world. So when we make statements about Harry Potter, right? We're not talking about what exists in our world. We're talking about what exists in this other hypothetical. So we're not committed to saying that Harry Potter exists robustly, okay? But Platonists are going to disagree, right? When we predicate primeness of a number, right, of that object is going to exist just as robustly in the same sense as when we say that the computer in front of you exists. Okay, so it's not this like weird sense of reality or realness that that others might think of in terms of, oh, well, this is real in this world. It's like a kind of realness or existence that is just as robust as when we say that you and I exist. Okay, I've been talking a lot, so I don't know if we want to stop here. yet. But there are a couple other criteria. Yeah, go ahead.
Oh yes, I did want to interject. Just to also keep the reader's interest, this is extremely relevant to the intelligent design debate. Now that, as Danny was talking, it began to spark a lot of recollections when I was early into the ID movement, because there are things about math. It's amazing if we take the top scientists in the world, and if we include lump mathematicians in there, they're more friendly to the idea of God than biologists, and it's partly of this idea of something eternal and unchanging and independent of our minds, independent of the physical universe. That's a little bit, can be a little bit unsettling. So I'm going to share my screen, and I'm going to just to show some of the Platonists out there, and there are many. They may not be creationists, they may not be even theists, but they're individuals like Nobel Prize winner Roger Penrose. I was surprised he won the 2020 Nobel Prize in physics because of his mathematical work. Actually, it says he got one half of the 2020 Nobel Prize in physics for the discovery that black hole formation is a robust prediction of the general theory of relativity. So maybe that was a long.
I wanted to add the other famous philosophers, like people certainly, if you know anything about modern philosophy, you might know about Bertrand Russell, or if you're into math, Kurt Gödel.
Oh yes, oh yes.
They're Platonist.
I didn't know Russell is a Platonist, and he's an atheist.
Yeah.
That is what you just said is very amazing.
Gottlob Frege was like Frege basically inspired most of Western philosophy as it is today. He's one of the big. He's like the Plato of ancient philosophy for modern, right? Quine, another huge figure in the 1950s, 60s, who I don't know. One of his students was Donald Davidson. I don't know. Maybe for my philosophy people, you should know these terms. Like if you're students, right? But this Platonism, I think the percentage of today's philosophers, 30 or 40% of them are Platonists.
And then it's like implicitly the thing that I got from my reading of math. Most mathematicians are, operationally speaking, Platonists. They may not go deep into metaphysics, but the way that they do their job is assuming these abstract entities have an existence independent of the mind. And the reason that's operationally important is you have the feeling that if you arrive at a theorem, that someone else can independently arrive at the same conclusion. That's pretty important. That's pretty important that one gets the feeling that if you don't discover this, someone else will.
And I am actually a Platonist myself.
Thank you for sharing that.
I should have said that in the very beginning, but there's other criteria that you mentioned, right? This idea of eternal, and I will give you an interesting argument or an interesting view.
Oh, Danny, could I?
Yeah, go ahead. Yeah, finish this. I'm sorry. Go ahead. My bad.
So that's one Nobel Prize winner. I would wager that another Nobel Prize winner. And it wouldn't surprise me if most of the Nobel Prize winners in physics were, because of the sheer number of mathematicians that are Platonists. I think you'd have a lot of closet Platonists who are first-rate physicists. So one of them is Eugene Wigner, and he talks about the unreasonable effectiveness of mathematics in the natural sciences. It's a very powerful essay. He wrote this essay. He published it a year before he won his Nobel Prize in physics. So he was just wondering, he said, why does the universe seem to match these certain mathematical patterns that are accessible to human minds? And this was actually a theme. A lot of people don't realize that fine-tuning isn't just about life. It's about fine-tuning so that the Platonic forms are the sorts that humans can comprehend. And William Dembski, commenting on a book by Mark Steiner, was pointing this out. He said, there's no reason this sort of correspondence should exist. It's actually pretty shocking. It's again extending Wigner's essay. And as I pondered this, I said, yeah, come to think of it, that is really kind of miraculous. And I remember one of my favorite physics professors, the first day of class, he said, yeah, it's just amazing what we can do in, with science. It's miraculous. And I'm just like, yeah, anyone that really is sensitive to these things will, if you read, you don't even have to read between the lines. You just have to find them in the piles of writings of some of these scientists like Einstein. He'll say that that's the one great mystery. Why do we comprehend anything? We shouldn't be able to. And computational scientists understand this. So I'm going to show one thing. When we're talking about objects that don't exist in space and time, I showed you the picture of Penrose. Let me see here. Roger Penrose. He is the co-inventor or one of the co-founders, along with his dad, Lionel Penrose, this impossible triangle. The impossible triangle cannot physically exist in our Euclidean world or quasi-Euclidean world. It just doesn't exist. But there are mathematical worlds that we can construct where this impossible triangle can exist. And there's some very interesting optical illusions that we can build with this. So there's a lot of math that explores other worlds that don't really match ours, and it's very interesting math. Now, every now and then we'll stumble on something that we thought definitely didn't correspond to the physical world, but then it starts to pop up. Probably the most famous example is non-Euclidean geometries. We found it to be a very useful way to describe aspects of general relativity. So I just wanted to, the reason I'm pointing all this out is for the math and physics students and who are non-philosophers like me. This is a lot bigger deal than you may realize, because I'm pretty sure that if the curriculum you guys went through was like mine, we didn't even think about this. We just kind of, it's like, okay, I just need to solve this theorem. I need to submit my homework, pass the test. I don't think about these deeper issues. But hopefully our viewers who are watching this will start to maybe ponder this, because it relates to the questions of intelligent design and information theory. And I would argue even things like the idea of what is a machine and what is a function, because those are terms you don't see. As a physicist, you don't say, oh, the electron is a machine, or at what point do all these assemble, or a chemist, it's like, at what point do all these molecules, at what point do we classify it as a machine? That's not a chemical idea. It's not a physical idea. What is it? And why does it dominate engineering? And why do engineers project it so naturally onto biology? And part of it deals, I think, with the idea of Platonic forms. We have a Platonic form for what constitutes a navigation device, for example. So a bird wants to fly from the North Pole to the South Pole. It needs a navigation system. An engineer understands what a navigation system is. You talk to some evolutionary biologists, they try to describe it in terms of natural selection, and we just laugh. I'm just like, what does that have to do with anything? And yet it's such the natural language of biology. And so I'm just trying to invite the viewers to keep listening to Danny here, because this may be getting down into the weeds of philosophical stuff, but this is important because the reason I wanted to host this show is I've heard some people describing information theory in terms of the supernatural and in terms of non-material. I'm just like, no. You need to clean up your language. Maybe you're not too far off the mark, but you need to clean up your language a little bit more and get it kind of a little bit more rigorous. That's why what you just told me about Bertrand Russell, that's really important. You can be a Platonist and not have to necessarily invoke the supernatural. It's probably pretty subtle how that can be done, but that's kind of where I'm headed. We just need to try to be a little bit more minimalistic and try not to conflate too many terms. That's kind of my goal today, because then we can move forward a little bit more effectively by using well-regarded ideas. I'm not saying that we've proven one side or the other, but it's been at least well thought out, much more than some of the stuff that I've heard on the internet where people are just spouting their opinions. It's like, sorry guys, I could tell you haven't really thought about this deeply. So go on, Danny. Thank you for
Yeah.
letting me hear my opinion here.
Yeah, of course. So they're basically, and we talked about a couple of them, but they're basically three criteria for a Platonist, right? We talked about that they're abstract, right? And that has connotations of eternality, of being outside of time, not engaging in causal relations. We discussed that. The second one is that all knowledge of these things or these mathematical truths are going to be, they're a priori, okay? So in philosophy, there's a very important distinction. One of the first distinctions you would learn in a philosophy 101 class is the difference between a priori and a posteriori. Okay. Now, what these categories are about how we come to know things. Okay. So if I gave an example like, Joe Biden has been president for let's say I don't know, it's been a month maybe. Joe Biden has been president for less than a month. Okay, that you might have to investigate the world, right, to know that. You have to look at an interview. You might witness the inauguration, and you might see what the day's date is. That you might acquire this knowledge a posteriori, right? A posteriori. Sorry, I said that wrong. A posteriori. Okay, so that's knowledge from experience. The only way you're going to know that Joe Biden has been president for less than 1 month, right, is that if you kind of investigate how the world is, right? Now, once you know that, you can make some inferences, right? Would it be true that President Biden has been president for 1 year if you knew that he's been president for less than 1 month? Well, if you found out that he's been president for, I don't know, X number of days, less than a month, right? You can make an inference that he hasn't been president for 100 years or 5 years or whatever. Now, that new knowledge, while it may not seem new, those propositions are different. How you got one from the other wasn't through experience, right? It was a priori knowledge, okay? So Platonists are going to think that the way that you've come to mathematical conclusions is not a posteriori, right? It's a priori, meaning that the way that you come to know all these mathematical conclusions is not going to be based on some kind of investigation of the world, right? In principle, you can reason through it. You could sit in your armchair and actually work out the problems in your mind, right? And that is something that's understood apart from experience, right? So Platonists are going to think that knowledge of mathematical objects or mathematical truths are a priori. There were certain people that disagreed. Of course, like John Stuart Mill thought that you come to know mathematical truths through the physical world. Now, I think Gottlieb Frege, right, a very important philosopher, completely dismantled this view, is pointing to stuff like infinities, right? First of all, there are different sizes of infinities, in case you didn't know. For the viewers, I know, of course, Sal knows. And they're extraordinarily large numbers, right? Numbers that go beyond the number of presumed particles in the universe, right? But we have a concept of them nonetheless. We have a concept of all these extraordinarily large numbers, all these sizes of infinities. Well, we could have not gotten that from the physical world directly. We had to reason to it or work it out in our minds to recognize these objects like infinities, right? So a Platonist is going to think that, you can come to know mathematical truths and know about mathematical objects just sitting in your armchair. You don't have to do a study of the empirical world, right? So they're going to...
Could I add one thing? The powerful thing about that is you also have the expectation someone else can independently arrive at it, which is actually, I think, really shocking, because when you hear people on the internet just spouting their opinions, they're going to disagree. But the thing about the Platonic world, for some of these theorems in math, you don't see disagreement. Everyone believes there is a right answer. And that's what shocked me. And that's actually why I get along with people who are mathematically minded. It's like, okay, we can be sure of this, and this is the right or wrong answer. And then we could say we don't know the answer right now. It doesn't get into the debates that I just see going on the internet. And that's very satisfying, the feeling that there is a right answer and other people can arrive at it independently of you. There's just something, that's why I was saying, I'm not going to argue Platonism is right or wrong, but it works. It works. And
Yeah, it
it's with
solves some
enough.
problems. It solves some problems for sure. And I wanted to give so Frege is one of the big shots. I've been saying to him over and over again. He's the one that basically, in the modern, like the last two, I think he died in 1925. I don't know, so I don't know when he was most active. But the point is that he really pushed Platonism like none other in the modern, like in the last 150 years. Okay, so I read his book, or at least the beginning of his book, and he talks about basically all of this. Now I think dismantled Mill's and Mill's view of that we can understand mathematical objects just in terms of physical terms, right? In terms of physical objects, right? He dismantled that, but there's also another view, right? That that the idea that these objects exist in the mind. That's sometimes this is called psychologism. Sometimes you might hear some kind of, it's called either psychologism or conceptualism. And if you read the first chapter of his, I think it's Principles of Arithmetic, I think that's what it's called. It's been a while, so I'm sorry if I get the title wrong. If you read that, he points out, well, number one, to what you were saying, Sal, we don't want to say math is a psychological endeavor, right? People have different psychologies. Does that mean they're different mathematics, right? So there's a problem there, right? We want to say there's kind of an objectivity to it, right? Whereas it seems like psychologism or conceptualism might kind of, it might diffuse that objectivity and just make it about a subject. The truth value of 2 + 2 = 4 depends on your thoughts. That doesn't sound right. Not according to Frege, right? There are other things too, right? Presumably the set. Go ahead.
Does that have some relation to postmodernism too? I mean, we don't learn postmodern math.
Yeah,
I totally interrupted you. Can we just say that thought for later? I disrupted your train of thought. Please go on.
It's fine.
I just had a spark of inspiration. I just had to throw that in there.
But very quickly, postmodernism. I don't know a lot about it, and it's honestly not taken too seriously in the analytic tradition. Postmodernism comes from other philosophical traditions like continental philosophy. I'm from the analytic tradition. Okay.
So when you said this psychological arithmetic, I said that reminds me of postmodernism. It's just like,
I see what you mean.
And that's just really distasteful to anyone who does math. It's like, no. I mean, it's not subjective. That's just like heresy to say that.
Yeah. And there's other issues too. Like for instance, think about the natural numbers. They go on to infinite, right? And you can have beliefs about each number. Okay, but you don't have an infinite number of beliefs, right? That would be a problem, right? Presumably your mind is finite, right? And so there are problems there with infinity. If infinity is grounded in the mind, well, then you've got really big problems in terms of infinite numbers of beliefs that you're not aware of, right? Whatever that means, right? What does it mean to say that you have all these beliefs, but you're not aware of the set that go on past, whatever the greatest number that you are aware of, right? So there's problems there. So Platonism is a response to someone like Mill and some of the people that are proponents of psychologism and conceptualism, and I think it really solves some of those issues, right?
So you called it psychologism.
So you might see two terms. There's psychologism or conceptualism. Sometimes you might see it that way, right? Psychologism usually just refers to the mathematical abstract stuff, but the terms are kind of, I would recommend everyone read, if you're interested in this topic, read the first chapter of Frege's book, right? It's actually relatively short and very succinctly written and very clear, I think. So Frege says, okay, it's not in the physical realm, it's not in the mental realm. So he literally calls the realm of abstract, where the objects exist, he calls it the third realm. So Plato would call it like the Platonic realm. There might be a Platonic realm. Well, Frege's terminology for the Platonic realm is called the third realm, and many philosophers kind of adopted that either that terminology or that kind of view.
this is all very powerful because, as you said, maybe 40% of philosophers subscribe to that. But
Mhm.
I'd say that the practicing mathematicians and physicists, even though they may not explicitly say that, the way they go about their business is implicitly that way.
Yeah, when you
Just
talk
like I
to
said, I mean, the professor would throw a theorem out there. He said, this hasn't been proven, but we expect, if it's decidable, there's a right or wrong answer.
I did take a course on philosophy of math a while back, and I'll just tell you my experience, and based on what my professor says and the interactions I had, there is I don't want to call it a tension, but between philosophers of math and then actual mathematicians, right? Mathematicians, according to my anecdotal experience and what was told to me, don't really care, right? Now, they might be, I think I might agree with you that implicitly they're talking about these objects as if they're real, okay? But they're not, there's unfortunately a big gap of communication right now between the mathematicians. There's like, I don't care for all that metaphysics and all that philosophy stuff. I'm doing math, it works, and that's the end of the story, right? A lot of them have that attitude. So, so really what I'm saying, I mean,
Well, that was I mean, again, that was my background. It's like, I just need to get this done.
right, they,
Make the
they
great,
got,
that's all I cared about.
right. Now, there are some really weird views out there. For instance, like people like Michael Dummett don't want to say that mathematical statements are true or false. Rather, they're either proved or unproved. So he takes out truth. There are people that try to take out the truth and falsity of 2 + 2 = 4 and just say, well, that's proved by a set of axioms or theorems or whatnot, right? So there are different views about how mathematicians are going to regard philosophers of math or metaphysicians, logicists, not logicists, but philosophers of logic. But then the mathematicians are just usually, look, 2 + 2 = 4 is true. 7 is a prime number. That's the end of the story, guys, right? So there's a disjunct, like there's kind of some kind of disjunct between the worlds.
Well, I see, at least in my program, it came up a little bit because they're talking about set theory. And whenever you talk about set theory, you can't exactly exercise out the metaphysical. It will come up in the literature,
Mhm.
and they talk about axiomatic systems. And so it did come up. It was enough to stir my interest, but then again, most of the time I'm just working on the math. But what I have seen is some of the very top mathematicians or physicists, like Roger Penrose is a mathematical physicist. They think some of the brilliant ones that are at the very top tier, they talk about it because they're going to encounter it at some point. Some of this starts to, they begin to.
Like, oh, what is this? Yeah. Mm-hmm.
I mean, part of it is they actually will describe, they'll create these mathematical systems and they're not sure whether it's described, whether that phenomenon is even possible in the physical universe. Because sometimes they'll go down some of these mathematical pathways. I've actually had some solutions to general relativity that came up in my computer, and I apologized to the professor. I said, well, I know this can't possibly be right. I can't find out where my error is, but look what the computer look at the solution it came up with. And one time we were laughing. We were supposed to find the geodesics to this unknown system in relativity. I mean, it's known, but he didn't tell us ahead of time what it was describing. And we were all struggling with it. And we got our homework back after we just miserably went through this exercise. He said, well, this describes a wormhole and we don't think it's real. It would require negative mass. And everyone laughed. I said, you put us through all this and now you're telling us that was just, that's just fiction. And we just all laughed. So the point is that we probably, anyone who does the physics, just as part of their job, they're just going to explore some of these mathematical possibilities. And maybe some of the time it just doesn't appear in the physical world. And so then you begin to have these thoughts. It's like, okay, does this exist? Does this platonic form of, say, a wormhole exist somewhere? Just like the impossible triangle that I showed at Penrose. And it's like, it's kind of, it's like, goodness, like what you said about the a priori, you could build all these theorems around it, and it's like, yeah, it's kind of hard to run away from kind of the feeling it, this third realm.
Mm-hmm. Yeah, it's and I mean Platonism. So we talked about a priori versus a posteriori. We talked about abstracta, right? And there is, I think that there's one more criteria. I think I went over it, but there is a disagreement in terms of their ontology, right? Whether they were actually created or not, right? So there's an interesting view in theism. So since you want to relate this to intelligent design, I will talk about this very briefly. A lot of philosophers don't know about this because I'm interested in philosophy of religion, so they kind of discount a lot of theistic understandings of Platonism. But I think J.P. Moreland takes the view that God created the abstract objects, right? And this is called, I think, absolute creationism. Okay, so it's an interesting.
Never heard of it, by the way.
Yeah, so it's not, God didn't just create the universe, but he created the objects, the abstract objects that are that we can have attitudes towards or concepts of as well, right? Now that's actually a minority view among philosophy of religion. A big majority view of philosophy and religion is something called divine conceptualism, and that's where these abstract objects, well, they don't exist independently, but they only exist in God's mind. So the number 3, or the statement that 7 is a prime number, that doesn't exist in our minds as human beings, as created beings, but rather they exist in the eternal mind of God. And when we have a concept or an attitude towards a mathematical proposition, our attitude is of God's thought, right? That like, let's say that the 7 is a prime number or something. But anyways.
And I wanted to say something that's very interesting. There's some things in mathematics that if you deal in the finite realm, it looks pretty straightforward. When you deal in the infinite realm, things get really interesting, and free will and choice start to play. One of the things, this goes into the creativity in mathematics. There are these conditionally dependent infinite series, conditionally dependent convergence. It's Riemann's theorem. And you have this infinite series, and you can add it up in any way you want, which seems interesting, and you can make any number you want. And one atheist mathematician by the name of Jason Rosenhaus said, that's why I wanted to study mathematics, because it's so cool. I'm sorry. And you can almost see then that, oh my goodness, we can create other realms if we just choose to perceive something a certain way, and it's going to play out. And it's a little bit shocking because it kind of violates our understanding of determinism. For the finite realm, 2 + 2 = 4. In the infinite realm, the way you may like these conditionally convergent infinite series, it's not so straightforward, and it's troubling yet also very compelling. And there are a lot of things like that, which I began to see the universe in a different way. I actually started to be exciting. I said, that there's almost like a free will there, and that was very surprising, because I always thought math is definitely deterministic until I started to look at some of these questions, and then the thing with Gödel, and I'm like, wow, reality is way more interesting, even in this Platonic realm, which kind of surprised me that the way you choose, basically what's happening is, let's say this infinite series is a Platonic object. It can change depending on how you choose to perceive it. So yes, there is this sense in the Platonic realm that it's eternal and unchanging, but not everything. There are some things that are a little bit supple, and that's one example.
I will say
there are not many examples of that, but that was exciting for me personally.
Yeah, I will say that most Platonists are going to be somewhat resistant Because you talked about determinism and free will, and the idea is that if there's a causal interaction between an object and, let's say, you, then the Platonist is going to say, well, that object isn't abstract anymore. So that's the I guess that I just wanted to relate what you said to Platonism. It's fine to say. I think what you were trying to say is something like, well, we could influence the world in which we could that this realm of objects could exist that don't share features like like physical things might have. But they said a Platonist would say usually that if there's that kind of causal interaction, well, we're no longer talking about an abstract object.
I'm just posting this for the reader's interest, and what I'm just throwing on the table, just for what it's worth, and I'm not going to pursue it much beyond this, is that free will may actually also be a Platonic form. And it may have to modify some of our definitions of what a Platonic form is if we say free will and choice might itself be also a Platonic form. And so let me just, here it is. In mathematics, the Riemann series theorem, also called the Riemann rearrangement theorem, named after 19th century German mathematician Bernhard Riemann, says, if an infinite series of real numbers is conditionally convergent, then its terms can be arranged in a permutation so that the new series converges to an arbitrary real number or diverges. And so there's the proof of this theorem, and they're just showing how you can just take this series and make any number you wish, depending on your choice of how you wish to perceive it. And so I'm just sharing that for the skeptical readers that might have thought I just made this up. And there are other parts in mathematics where we see that this kind of suppleness when you start dealing with the infinite, things just start to they're just the world of possibilities that are just so distinct from what we see in kind of the finite world. And I don't know, it's just like certain kinds of music, people have to have a taste for it. To me, this is exciting. For some people are like,
oh
what are you
yeah,
talking
I think
about?
it's exciting. I'll say it's exciting as well. I know this kind of topic and the implications on the metaphysics and even just how you go about life, right? I mean, I think our society too much values while science is very important. I love technology. We're using technology right now. We lose sight of the other things that might exist differently. Like if I don't know if you wanted to speak to that or not.
Oh, Danny, we earlier had a power out and my computer just crashed. I don't want to lose this recording, and it may be that we can continue the conversation for another episode, because
Yeah,
we
that
already
sounds
had.
fine. That sounds great.
So I'm not trying to totally cut you off. Just for the sake of the readers, because I have to try to promote my channel and try to get them interested in the next episode. Um, I'll put a link to your channel and encourage people to subscribe in the video description.
I appreciate
Now,
it.
how this relates to information theory, just briefly for the people that are wondering why I'm exploring this. This is something that I studied in information encoding theory. And this is like what they call a constellation diagram, where this constellation diagram is an abstract entity that is generated by electrical signals across, say, a modem. And in this case, depending on how the electrical signals will conceptually create this constellation, it's kind of peculiar. What they call this, the quadrature amplitude modulation or phase shift keying. Oh, this was brutal mathematics in my communication information theories. But the idea is those electrical signals will map to positions on this conceptual circle. And the position on the conceptual circle will correspond to a number, to a binary number. So this is binary number 2. I think this is binary number 6. That's binary 7. Binary 5, binary 4, binary 0, binary 1, and that's binary 3. And so what's going on here? What's going on here? How is it that we are saying these electrical signals correspond to numbers? that's how that's part of information encoding theory, where the senders and receivers agree that, okay, if you get this kind of electrical signal, it means this number. But there's nothing in physics or chemistry that says it has to be that number. That's something we project on it. But again, these are Platonic forms. You're talking about the number 0, or like the number 7, and you have the number 7 here. So what we're trying to do with information, the idea of information is we're trying to make sure that if the receiver has conceived of a certain Platonic form and he wants if the sender has a Platonic form in mind that he wants to communicate to the receiver, we want to ensure that that receiver is going to agree that he received this Platonic form, or he's at least saying, okay, the sender was intending to send, to signal me that he's thinking about this particular Platonic form. Now, this is starting to give us an idea of what information theory is. So the idea of numbers being tied to information theory is pretty important. And maybe in the next installment, we can talk about, if it'd be okay with you, Danny, to talk about this Wikipedia article. It's very short. It talks about mathematical realism, which is a form of, and they say one form of the realism is Platonism, and there are various schools of thought. And there's
you see, there's Kurt Gödel's Platonism right there.
Yep.
You see that? Yeah.
Yep.
And then there's a priori right there. Do you see the term that we learned about? I don't know.
Yeah.
Mm-hmm.
This is such a fruitful discussion. Would it be all right if I just finish by reading this for the viewers? And we'll talk about this again. You actually enlightened me a lot on a lot of ideas. So mathematical realism, and hopefully people can see, you could just look this up on Wikipedia. Mathematical realism, like realism in general, holds that mathematical entities exist independently of the human mind. Thus, humans do not invent mathematics, but rather discover it. And any other intelligent beings in the universe would presumably do the same. In this point of view, there is really one sort of mathematics that can be discovered. Triangles, for example, are real entities, not the creations of the human mind. Many working mathematicians have been mathematical realists. They see themselves as discoverers of naturally occurring objects. Examples include Paul Erdos and Kurt Gödel. Gödel believed in an objective mathematical reality that could be perceived in a manner analogous to sense perception. Certain principles, for any two objects, there is a collection of objects consisting of precisely those two objects, could be directly seen to be true, but the continuum hypothesis conjecture might prove undecidable just on the basis of such principles. Gödel suggested that quasi-empirical methodology could be used to provide sufficient evidence to be able to reasonably assume such a conjecture. Within realism, there are distinctions depending on what sort of existence one takes mathematical entities to have and how we know about them. Major forms of mathematical realism include Platonism. And just for the sake of completeness, there's mathematical anti-realism. Mathematical anti-realism generally holds that mathematical statements have truth values, but they do not do so by corresponding to a special realm of immaterial or non-empirical entities. Major forms of mathematical anti-realism include formalism and fictionalism. So we have the contemporary schools of thought. The view that claims that mathematics is the aesthetic combination of assumptions, and then also claims that mathematics is an art. A famous mathematician who claims that is the British G.H. Hardy, and also metaphorically the French Henri Poincaré. For Hardy, in his book A Mathematician's Apology, the definition of mathematics was more like the aesthetic combination of concepts. Platonism. Mathematical Platonism is the form of realism that suggests that mathematical entities are abstract, have no spatio-temporal or causal properties, and are eternal and unchanging. This is often claimed to be the view most people have of numbers. The term Platonism is used because such a view is seen to parallel Plato's theory of forms and world of ideas, Greek eidos, described in Plato's allegory of the cave. The everyday world can only imperfectly approximate an unchanging ultimate reality. Both Plato's cave and Platonism have meaningful, not just superficial connections, because Plato's ideas were preceded and probably influenced by the hugely popular Pythagoreans of ancient Greece, who believed that the world was, quite literally, generated by numbers. A major question considered in mathematical Platonism is precisely where and how do the mathematical entities exist, and how do we know about them? Is there a world completely separate from our physical one that is occupied by the mathematical entities? How can we gain access to this separate world and discover truths about these entities? One proposed answer is the ultimate ensemble, a theory that postulates that all structures that exist mathematically also exist physically in their own universe. Kurt Gödel's Platonism postulates a special kind of mathematical intuition that lets us perceive mathematical objects directly. This view bears resemblances to many things Husserl said about mathematics and supports Kant's idea that mathematics is synthetic a priori. Davis and Hirsch have suggested in their 1999 book, The Mathematical Experience, that most mathematicians act as though they are Platonists, even though, if pressed to defend their position carefully, they may retreat to formalism. Just as a side note, that's actually what I'm arguing. It's like, I'm not trying to settle this, what's right or wrong. I'm just saying, operationally, it works if we just accept it as an operating principle. And that's all I'm just trying to say. It's fruitful. Full-blooded Platonism is a modern variation of Platonism, which is in reaction to the fact that different sets of mathematical entities can be proven to exist depending on the axioms and inference rules employed. For instance, the law of the excluded middle and the axiom of choice. It holds that all mathematical entities exist. They may be provable, even if they cannot all be derived from a single consistent set of axioms. Set theoretical realism, also set theoretic Platonism, a position defended by Penelope Matty, is the view that set theory is about a single universe of sets. This position, which is also known as naturalized Platonism, because it is a naturalized version of mathematical Platonism, has been criticized by Mark Balaguer on the basis of Paul Benes-Karoff's epistemological problem. A similar view termed Platonized naturalism was later defended by the Stanford Edmonton School. According to this view, a more traditional kind of Platonism is consistent with naturalism. The more traditional kind of Platonism they defended is distinguished by general principles that assert the existence of abstract objects. I'm not going to go any farther. This is not easy reading. I was stumbling through. I said, this is such tough prose to read through. It wasn't like when I was reading Snow White, all the words just flowed so easily, all the terms. And toward the end, there were some parts that I wasn't really that interested in. So when we build information communication systems and this idea, because information theory is brought up in the ID world a lot, I was just trying to relate what are kind of the implicit operating assumptions, like numbers are real things. And you could see how this debate could go back and forth for a long time. But from an operational standpoint, you assume that numbers are real things and they have properties, and that's why your machines are going to operate a certain way too. And so that's all that was the main thing I wanted to say. But it'll be a segue to some of my discussions on Shannon's theorems, Shannon entropy, thermodynamics, intelligent design, and information theory. Danny, I'm going to I please have the last word, and thank you for letting me read that. The main reason I'm just trying to cut this off is I don't want to lose this recording.
Yeah, I look forward to the next discussion relating these sorts of views to information. I will say, though, here's something I will say, that at least within my domain in philosophy, the notion of information is not a technical term. There's no consensus on the meaning, and because there's just so many broad applications of the word. So there's not a good, whereas like something like abstract, well, here's the traditional renderings of what that means. Information is just not very simple at all.
Exactly.
In terms of
by the way, that's the angle I'm going to take.
Mm-hmm.
So I will compartmentalize. I said, okay, if you're talking Shannon information, this is extremely well defined. Even algorithmic information, semantic information, it's like okay, because John Maddox keeps talking about code. It's like, okay, we can argue this, but you have to tighten up your language a little bit, so that, and then it's going to get even worse when we try to talk about function.
Mm-hmm.
But you can't. As you pointed out, it's so hard to run away from the idea of function and try to exercise it out of biology. I mean, someone's going to say, oh gosh, the bird has a navigation system. And it's like, oh, are we going to forbid that because that's a Platonic form? And that's just, it's just like, that's going to be hard to do because that's what it really is, you know? You talk to someone who's like who's been in the aerospace industry, where navigation and direction finding are really important. And for the bird to get from the North to South Pole, it's like, okay, what are you going to call what he does? I mean, come on, guys, you know, just even in practical terms. And you know, this triggers the evolutionary biologist when you start to use language like that. And it's like, I'm just trying to give it the right word. I mean, what do you want me to call it? And so it'll lead. So we'll start with the kind of like really clear ones when I was like showing the signal constellation. That should not be too, and we'll just kind of build out. But I think that's one way to conceive of it. And then maybe I'd like to address this whole thing about the code argument, because the codes are actually Platonic forms. They're not physical entities. And I know I'm going to ruffle some feathers. That's why DNA is not a code.
There's a lot to talk about then.
Yeah.
So next time, tune in.
I know I'm going to ruffle feathers. People have been insisting DNA is not a code. I'm just like, I mean, they'll say DNA is a code. I'm like, no. It is, codes are Platonic forms that are independent of the
right. At the very least, there seems to be some transcendence, right?
Yes, that's my point. And it's like, I get your shorthand, but it's not the most rigorous language. Formalists, like especially like you, Danny, and quasi-formalists like me kind of cringe when I hear that.
Not quasi.
So.
All right. I thank you for having me on.
This is going to be a lot of fun. So
y'all should subscribe to my channel. I am doing the Philosophy of Mathematics series. I've done 2 episodes already. I try to make it around an hour, but I do talk about Platonism. I think last week we talked about Kant's view of math, and we talked about a problem for Platonism called the integration problem. So if you're interested in all that material, you should look at it, subscribe, like, do what you do.
That's great. I'd like to thank all the viewers who've joined us through this recording, and I'll try to join the chat when I premiere this. I really want to especially thank Danny, who's given me a lot of information and insight, and I really value his knowledge of the whole field of philosophy. So he's describing a lot of things that I studied from a perspective that I wasn't taught when I was studying these things. So I look forward to our to future conversations. So to all our viewers and to Danny, take care and God bless you. Have a good night.